Let's take a look at the environment that is offered by default by the Bash shell interpreter. So we know that there are variables that are defined in our environment. We know that we can define our own variables and add them to the environment. But what I'm more interested here in this video is to give you a quick overview of some of the variables that are available by default in the environment on a Bash shell and what they are there for, pretty much. So we're going to use a lot of echo statement, and I'm going to showcase some of those variables. So let's start with echo $home. So the home variable contains actually the path to your home directory. So obviously if you are logged in as different users, you are going to get different responses. The same way that if you try to echo $user, well, you're going to get actually the username as which you are logged in right now. Okay, so all of those are going to change depending on who started the Bash shell, what user logged in and started their own Bash shell. Okay, talking about the Bash shell, we can also get information about what shell we are using. Okay, it's possible on a Linux system to use different shells. In this course, we are going to mostly talk about the Bash shell because it's a very ubiquitous shell, and it's a default shell for the Ubuntu distribution we're using this semester. However, you need to know that there are different shells. Each of them offer different advantages, different syntaxes. So you could actually possibly run a different shell, and if one of your scripts, for example, needs to detect what kind of shell it's running, you can do so by inspecting the shell variable, or you can even inspect the shell variable like I just did at the command line, just in case you wonder what shell you are currently running. Okay. So what else do we have that is actually worth mentioning? Well, we have hostname. Hostname is a variable that, as the name implies, stores your current host name. So if you are using different shells, just as a quick remark, you're going to see that some of them store this information into a variable named host. Here, using Bash, if we try to actually access the host variable, well, there's nothing inside of it. Right. So continuing through the list of the most salient variables that you're going to find in your environment, we have pwd. So pwd contains actually a current working directory. So it's the same thing that you would obtain if you type the pwd command. Okay. So if I move back one folder and I type pwd, I expect it to follow me, okay, to represent my current working directory. Well, so does the pwd variable. So it's a kind of a special environment variable insofar that it is updated every time you change your current working directory automatically for you. Okay, so what else do we have that's interesting? Well, we have one that is really actually interesting, echo $path. So the path variable contains a list, and the delimiter for the element between the element of that list is the colon here character. So the first element of the list here is /home/tux/bin. Then we have /home/tux dot local/bin. Okay, so the dot just means that this is a hidden directory under tux. Then the next element is /usr local sbin /usr local bin usr sbin usr bin /sbin/bin. Okay, so and so on and so forth. So we have a bunch of folders, and you can tell already that the theme, the running theme here is that all those folders have something to do with binaries, because they keep using the word bin. Okay, so these are folders where executable scripts or executable programs are stored on your system, and the path variable is a way to tell the shell when the user is typing a command like ls, what are the folders that I need to go through, in which I need to look up for a ls executable command, whether it's a script or whether it's a compiled binary, it doesn't matter. Okay, but this is the order in which things are looked up. So that means that if there was on your system two different executable files named ls, okay, two different binary compiled version of the ls command, one located inside of /home/tux/bin, so a bin subfolder inside of your home directory. This is a ls executable that you have been working on as a project, and you have been compiling it. And then there is a standard ls, and I don't recall exactly where is ls, so I'm going to just ask, okay, where is ls? That's actually a useful command. /bin/ls, so there is a version in /bin, there is a version in your own /home/tux/bin. Well, the one that's going to be executed when you just type ls like so at the command line is going to be the first one that is encountered by following the path. So in this example, that would be the one in /home/tux/bin, okay? So the path is really relevant to configure things. Like if you add software on your system and this software has binaries that need to be available at the command line, well, you'd better make sure that when you install that software, the installer does its job properly and drop those binaries somewhere in those system-wide folders that are meant to hold binaries and executable, okay? Or if you are developing a program yourself and you know that the binaries are in /home/tux/myproject/bin, well, then you can easily add this to your path variable, okay? So the way that you would do that is, well, there's a way to do it temporarily, okay, just for the duration of the session. So you would say my path is actually my current path. So the value that I want to assign to the variable path is the current value of the variable path, and then I want to append at the end /home/tux/project/bin, for example, okay? So you could do that, all right? There's no problem there. You can append at the end, you can append at the beginning also. It depends on whether you want that folder to be searched first or last, you know, whenever you try to execute any command. And the consensus is that you should always append local things like that at the end, okay? And the reason for that is that you don't want to, for example, have a binary named ls in your project and suddenly have that binary override any execution of the ls command for anything that's going to follow the path. So for example, you are running a bash script, and that script invokes the ls command without any precaution. So by default, the bash interpreting that script is going to look for the ls command in the path. If you put your tux project bin folder first and it happens to have an ls that does something completely different, well, then tough luck. This ls is going to be used, you know, in that other script, even though you didn't intend it for it to be used in that context. So it's good when you have like a specialized version of things, etc., to put the directory where those binaries are at the end, so that you use actually the appropriate system-wide default version of the executable first. And if you cannot find the command you're trying to run in any of those default folders, then you start looking into your own personal folders, okay? So here's an example. We just change the variable path, the content of the variable path, and you can see that I have my HomeTux project bin now at the end. So the path variable is something that's really useful to know about, okay? Whether it's in your Linux, Windows, or any operating system, generally there's an equivalent to the path variable. Another variable that is interesting to explore is random. Equal $random. So here's the deal with random. It's kind of like the PWD variable, insofar that it is not holding a constant value that's never going to change. It is updated on, you know, without you having to do anything regularly. So in the case of random, every time you read the content of the variable random, you are going to get a random number, hence the name. Okay, so I do not remember exactly the range for that random number. You can check it out in the bash man page, I guess. But the bottom line is that it's a quick and easy way to generate some pseudo-random numbers. So now what we're going to do is we are going to use this random variable to illustrate something that we already talked about before, which is quoting, and illustrate it into a new context, which is a context of your shell prompt. So, first thing first, the shell prompt that we are using can be modified. and there is a special syntax to do so, okay? But more importantly, there is an environment variable called PS1 that actually describes what we want this prompt here to look like. So this is using escape code that are meant to allow the display of different colors. It's using some special escape code like /w, which mean the host name, for example. So there is a very special syntax. You can see that it's using also variable, like there is a variable here, Debian_ch root that is used, but we use that syntax to access the name of a variable that is the $sign and the curly braces here and here. But inside we do something that we haven't learned to do yet. We do something about substituting a sort of default value, you know, to the variable if it's not defined or something like that. So pretty much the syntax is a mix of using color escape code and using escape code that are specific to PS1 that means some specific things, like this means the $ prompt, this means the host name, there should be the username somewhere, there we go, username at hostname, sorry, /w is not the hostname, it's a working directory, okay? So /u is the username here, tux, at /h, and then somewhere here we have the working directory, blah blah blah. So there's a whole syntax that lets you explore that syntax on your own if you are curious. But what is important for me, what I wanted to use PS1 to illustrate, is the fact that we can change very easily that prompt to say whatever we want. Okay, for example, what now with a question mark, and now this is my prompt. So it's not really a useful prompt because I lost all the interesting information that I had before about what user am I logged as, what hostname am I working on, what is my current working directory. So, but bottom line is that yes, you can replace your prompt inside your session like that simply by changing the value of PS1. So I'm going to use that to illustrate something about the random variable and the way it interacts with quoting. So let me start by doing PS1, export PS1. This is an example that you're going to find in all sorts of textbooks and tutorial, okay? Your lucky number is, and then I'm going to use random, okay? And then I'm going to put a space here so that I can have a space after my prompt and type my commands. All right. So now I have a prompt that is really not much more useful than it was when I said what now in the prompt, but it displays my lucky number and I can enter commands and it doesn't do much more. But here's the bit that's a little annoying, is that it displays a lucky number and that lucky number doesn't change, okay? So what's happening here is that I use double quotes. So that means I neutralize every meta character except, one of the meta characters that's not neutralized is a $. So the shell actually assigned to PS1 the value your lucky number is, and then whatever was inside of the variable random at the moment where I interpreted this double quote expression. So the number that was there was 25,668. So the string that was assigned to PS1 was your lucky number is 25,668, and that explains why now my prompt is fixed to be that number. So what if I want a prompt that every time I enter a command and I get the prompt again, every time I get the prompt again, I am going to have a different number? Well, this is feasible. Let's explore how we can do that. Export PS1 equal single quote. Your lucky number is $random. So I didn't change much, right? I just switched from using double quotes to using single quotes. Let's see what I have. So I get a new number, but that's normal because I reevaluated the variable random, right? So that doesn't mean much, but look at what's happening. Every time I issue a command and I get a new prompt, I get a new random number. So why is that so? Well, here's the deal. When I assign a value to PS1 this time, I used single quotes, so strong quoting. And that means that this is character for character what was assigned into PS1. your lucky number is space dollar opening curly brace random all in uppercase closing curly brace space. So that is what is stored right now in PS1. So every time the shell is displaying my prompt, it is looking inside of PS1 and it's trying to again interpret PS1. So interpreting PS1 means that if I had like special code like /u/h/w for username, hostname, and current working directory, it would interpret them in the current context. So it would look at who I am logged as, what is the hostname value, what is the current working directory, and replace those in the prompt that it displays. Okay. Well, in this case, I could also use things like $pwd. Okay, I could use things like $user and $hostname, right? In my PS1. Well, in my case, I use $random, but I used it in a way that when I assign the string to PS1, I prevented the shell from trying to replace that value by whatever it is currently, and thus pass to PS1 and to the part of the shell that is displaying the prompt value that is fixed once and for all. Instead, I said pass curly braces and then the name of the variable in there. So that means that every time the shell is displaying the prompt, it interprets PS1 as telling it to look at what is the current value of random. If I do an echo of PS1, you can see that this is exactly what's happening here. Okay, the PS1 variable, environment variable, explicitly reference the fact that we need to look inside of random for a value. Okay, so that's actually a pretty neat example, just to illustrate, how the quoting mechanism can influence what you can do with your shell. If I go back to export, with PS1 using export PS1 value using double quotes, then if I try to do an echo PS1, you can see that this is a value that's stored once and for all in PS1. So whenever the shell displays your prompt, it doesn't have anything to evaluate here, it just displays the string. When the shell displays your prompt in the previous example, it shows clearly that it has something to evaluate. It has to evaluate a variable named random, and this is why it gets different random numbers every time. Okay, so like I mentioned, there is a whole bunch of syntax here that is accompanying what the PS1 prompt and environment variable. Let me show you real quick. Again, I'm going to use the Harley-Hen tables. There we go. So this is illustrating, and we're not going to look at the over column here, C shell, corn shell, TCSH. These are for over shells. So we are mostly interested in the bash column here, okay? And it shows you what are the different codes that you can use in PS1 to indicate that you want to insert some special value, okay? So for example, the hostname \h. So if I was going here and I said, okay, I want my PS1 to be so user at hostname, and then between between the square bracket, I'm not sure if I need to backslash those, so I'm going to backslash them just to be sure. Between square bracket, I want to display my current working directory, okay? And then I display a colon and a space. So if I want to pass that to actually PS1, notice that I use a single quote so that the backslash of the square bracket was not really necessary, but bottom line is that I pass that string to my shell via the environment and via the environment variable PS1 more specifically, and now my shell is very happy every time I am redisplaying the prompt, to update it according to this code. So there are plenty of different codes here that you don't have to learn them by heart, but I would suggest that you jot them down somewhere in your notes so that you are capable to find them should you need them. If you look at the bash manual page and you look for the PS1 or prompt entry, you're going to be able to find similar information as well. Okay. The other thing that is of interest for when you are trying to build a prompt, which by the way, building a specific prompt is a nice little exercise for quizzes, exam, and whatnot. So I would recommend that you practice that a bit. Another thing that is relevant is what kind of environmental variables are often used when you try to compose a prompt. So this is just a sample, okay? So home, host, you can see that we even have shortcut. So home, host name in the case of bash. The ones that you want to look at are really the ones that have a B here in the first column, because once again, the Harley-Hand textbook discusses multiple shells. We are going to focus on the bash shell in this course. So all of those variable name except host, that is not used by the bash actually, are available in the bash shell to try to display some specific information in the prompt. So you can get very, very fancy with your prompt in a Linux system, even without going into the whole color code and stuff like that, but simply by looking at what kind of information you can embed in your prompt, you can do some very, very interesting things with the basic syntax.